Dear viewers, I welcome you all for a lecture session on the topic of scanning tunneling microscope. So these microscopes are widely used in both industrial and fundamental research to obtain atomic scale images of metal surfaces. It provides three-dimensional profile of the surface. Thereby, characteristics of any surface can be determined. So, we'll discuss about the construction and the working of the scanning tunneling microscope in this video lecture. So, this scanning tunneling microscope doesn't work the same way as a conventional microscope, that is using optics to magnify the sample. Instead, it has a sharp probe of 1 to 10 nanometer dia that is electrically conductive. This is made to scan over just above the surface of an electrically conductive sample. An extremely fine conducting probe is held above about an atom's diameter from the sample. The electrons tunnel between the surface and the tip, producing an electrical signal. While it slowly scans across the surface, the tip is raised and lowered in order to keep the signal constant and maintain the distance. This enables it to follow even the smallest details of the surface it is scanned. And this is an STM is an electron microscope that uses a single atom tip to attain atomic resolution. So can you look at the diagram here? So this shows this is the sample and this is the probe tip which is moved above the sample. So thereby a current flows between the probe and the sample. So this current is nothing but the tunneling current. So we'll see what is tunneling current and how it is generated in subsequent slides. So in the tunneling is a phenomena that describes how electrons flow across two objects of differing electric potentials when they are brought into close proximity to each other. So when a voltage is applied between the probe and surface, electrons will flow across the gap, generating a measurable current, and that current is called the tunneling current. So this is the probe. You can see here the arrangement of the tunneling current here. This is the sample surface and this is the probe tip. So the important characteristic of tunneling is that the amplitude of the current exhibits an exponential decay with the distance d. That can be described by this equation. I is approximation to V e power minus c into d, where V represents the voltage between the probe and the sample and C is a constant, D is the probe sample separation distance and I is the tunneling current. So the tunneling current depends on these factors. One is the voltage between the probe and the sample and the distance between the probe and the sample. So the key factors for STM includes, these are the key factors. Very small changes in the probe sample separation induce large changes in the tunneling current. That is, at a separation of few angstrom, the current rapidly decreases. Next key factor is the dependency on the tunneling current and the probe sample distance allows for precise control of probe sample separation, resulting in high vertical resolution. Furthermore, tunneling is only carried out by the outermost single atom of the probe. This allows for high lateral resolution. And this is the block diagram representing the various components present in a scanning tunneling microscope. So you could see here, this is the sample, and you have a probe, and you have the circuitry, and you have a feedback loop. Okay, so all these forms up a scanning STM. So in STM, when a voltage is applied between the metallic probe and the sample, typically the voltage will be around 0 to 3 volts. And when the probe is close to the surface, when the probe is close to the surface, the distance will be 2 to 4 angstrom. The voltage will result in a current due to tunneling between probe and the sample. And when the probe is far away from the surface, the current is 0. The tunneling current produced is low, but can be monitored using amplifiers. So you have a 3D scanners with an electronic feedback loop is used to raster the probe across the sample to obtain the topographical image and monitor the tunneling current. So I believe you could able to understand the construction and its working of a scanning tunneling microscope. Coming to its applications, so this is widely used in both industrial and fundamental research to obtain atomic scale images of metal surfaces. It provides a three-dimensional profile of the surface, which is very useful for characterizing surface roughness, observing surface defects, and determining the size and conformation of molecules and aggregates on the surface. Thank you for watching.